Who likes to work with database via UI? Raise your hands. Okay, all right, all right. How about IDE integration, like an IntelliJ plugin or Visual Studio plugin? Okay, and how about CLI? Just straight up CLI. So it seems like a lot of UI in here. That's you know, don't be ashamed of that. It's okay to use UIs. It's fine. I like UIs. I'm a, you know, old school database guy. I like using UIs. I like graphics. Okay. How about ORMs? Who uses ORMs? Raise your hand. Like Hibernate or Entity Framework, something like that. Okay. What about I don't know, Spring Data? How about Spring Data? I guess that's an ORM, kind of. I know there's at least one. Okay. All right, it's 11:30 now, so it's time to put this away. Like I said, come by the Couchbase booth later if you've got more opinions. Love to discuss that with you. But today we are talking about putting the SQL back into NoSQL. So welcome everybody. If you're like most developers, you probably already know how to write SQL. Kind of looks something like this. Even if you only have a passing familiarity with SQL, this is still something that's easy to read, I think. It's concise, it's declarative. It says, give me everything from inventory where the price is a certain range, and it's on sale, or there's less than 20 of them left. I think that's pretty readable. Even if you're not a SQL expert, I think that's understandable. This is a screenshot from the documentation of a popular NoSQL database. And this query returns the same results, but I would argue that it's a little harder to read, it's harder to write, certainly, and there are fewer people in the world who know this language compared to SQL. SQL, one of the most popular languages in the world. Yet, what choice do I have, right? I want the benefits of NoSQL, so I have to learn this sort of thing, right? Well, I think no. The answer is no. I think we can apply SQL to JSON data. So I want to talk about that today. We're going to talk about going from a relational data mindset to JSON. We're going to go through the basics of SQL++, and we'll show you how to get started. I'm going to have a little bit of a demo if we have time today, and I'm happy to take questions at any time. I can't move from this podium because I'm currently streaming right now, so everyone can see and hear me. But I usually like to walk around the room. But if you have a question, shout it out anytime, and I'll try to answer the question the best I can. So let's talk about relational data to JSON. So this is a small relational data model for a customer, right? This is the customer table. It's got a name, ID number, you know, whatever's in there. There's a billing table, which includes like payment methods and a billing address and so on. There's a contact table, which might include addresses, email addresses, phones, whatever. That's probably going to be 3 or more tables, but you get the idea there. Purchases, which includes a history of items that a customer has purchased, and so on. Connections, this is maybe customers' relations to other customers. Like say as a streaming account, I have multiple accounts on there, like my children, my wife have their own account within their own user within our Netflix account, that sort of thing. And there's maybe a social media aspect, that kind of stuff. So relational is very popular. I'm not going to get into all the benefits, but what are the drawbacks of the relational approach? And I think there are several we have to think about. So the first one is scaling. When the number of users of your application increase, so do the demands on the database. Legacy relational databases, they're often designed to scale vertically, you know, one big machine sort of thing. We need more scale, we need a bigger computer, more processors, more RAM, etc. And that can get expensive. Horizontal scaling is the other approach where you have multiple databases that shard that data, split it out amongst multiple servers. That's not impossible with relational, but it's difficult to do and complex to pull that off. Flexibility is another one. So making schema changes to a relational database, they can be painful. Sometimes they can cause downtime, just difficult to manage sometimes. So with a NoSQL database, you don't have those kind of constraints. Performance can be a problem. They have their roots in the days of hundreds of users, right? Work in the same office, that sort of thing. The data being flat and complex entities are modeled with multiple tables. So that makes a lot of joins, which means slower performance. And the last one's availability. So a typical legacy deployment of one database server means a single point of failure. And you can configure replication servers. Again, it's possible, right? But it's complex, it's time-consuming, can be expensive. It can also result in a performance hit, depending on the SLA you need for the backup of servers there. So these are the reasons that JSON document databases, NoSQL databases are at least considered as an alternative, right? Or possibly used in conjunction with these to try to address these issues. In a JSON document database, the data can be more centered on the root data. In this case, the customer. So we have a customer document instead of 5 tables and 10 plus rows split out in pieces in a relational database. Within the document, the associated data can be represented as arrays. So up here I've got billing as an array, connections as an array. It's all part of one document, one piece of data, instead of different rows I have to join together. So each document also has its own self-described schema. I would say it's self-described. So a developer could simply add a new field to their class in their code, like your Java object or your .NET object or whatever, and then saving that to the data would introduce that new field to that document you're saving it to. So there's no need to change schemas in the database itself, no need to manage those schemas. You can manage those in the application layer. And those closely map to your object. So instead of having to go through an ORM like Hibernate we were talking about earlier, you can now just serialize and deserialize back and forth directly between the objects and the JSON data. So side by side, I just want to show the left, a traditional legacy relational model. That's 9 rows of data in 5 tables. And the right is a a JSON document in a document database. So it's all together as one piece of data. So on the left, we got lots of joins, lots of overhead. We have to have ACID transactions to work with data over there. Lots of schema to carefully manage and change. On the right, a single JSON document in a document database. I can retrieve that whole piece of data with one operation, one get or one lookup to get all of that. And again, we can serialize it directly to and from our application objects. So then you might say, but at what cost, right? There are good things about relational databases. We do like them for a reason. They're popular for a reason, right? So these are 3 things that I think developers really care about when it comes to relational databases. And one of them is SQL. I mentioned that earlier. It's a fantastic language. It's easy to read. It's declarative. It's concise. Lots of training material. Lots of schools teach SQL. Lots of companies use SQL already. Joins are an important part of SQL. What if I can't put everything into one document, like my example back there? What if I can't put everything into one single? I have to have separate documents for a customer and an invoice, for instance. So I still want to be able to join data to each other. And ACID transactions, right? So not every use case can fit into one document. So I still have to have ability to update 2 pieces of data or more in one operation in order to provide data consistency. So these are good things about relational that traditionally haven't been in JSON NoSQL document databases. And that's where I think SQL++ really benefits the document world. So it's a semi-structured query language that encompasses both SQL and JSON data model, and it is SQL backwards compatible. This was something that was first created as an open source project at UC San Diego. And so you can go check that out, that open source project there today. Couchbase was the first database to actually do a full commercial implementation of that for SQL for JSON. And there's been some other document databases that have added at least a partial implementation of SQL++ or SQL for JSON. So Particle is an Amazon project designed to add SQL to DynamoDB. Again, it's not quite a full implementation, but it is a good start. Cosmos DB, that's an Azure-only offering that has a SQL option. Again, very small implementation of SQL, but again, a very good start. I also wanted to mention Apache Ignite. It's not a document database, but they do have a full SQL implementation for semi-structured data. So it may not have the full capabilities of SQL++, but it's something worth mentioning as a good example of this standard starting to be adopted by the NoSQL world. I also wanted to point out this cool little book here on the right. This is SQL++ for SQL users. This is something that Couchbase has published. But it's a book written by Don Chamberlain. Anybody familiar with the name Don Chamberlain? You really should be, I think. He is one of the inventors of SQL. So it's very cool to have him on board with the SQL++ standard as well. That's a free book. You can go to the link down there, if you can read that, at the bottom, to get a PDF copy of that book if you're interested in checking that out. So I'm going to go through the basics of SQL++ now and touch on joins and ACID transactions, and then we'll go from there. So let's start with a list of terms. Any questions so far before I get going into more of the technical stuff here? Okay. I'm not sure if you can ask questions at home, but if anyone can relay those questions in the chat or whatever to me, I'm happy to answer those as well. So this is a list of terms on the first column you'd see in the relational world. I'm using SQL Server as an example because that's what I'm familiar with, but similar terms in the Oracle and MySQL world. The second column is Couchbase. Again, it's what I'm familiar with, but you'll see similar terms in other document databases. And this is kind of how they translate to each other. So the first one is SQL Server has a server, obviously. And the equivalent in Couchbase is a cluster. So the difference here is that Couchbase is distributed. There's multiple machines, multiple nodes that make up a cluster of Couchbase. So that immediately right there, just having a cluster gives you scalability because you can add more nodes to the cluster, high availability. If one of them goes down, the system can stay up. And one other thing that Couchbase offers is also built-in caching. The next level down in SQL Server is called a catalog, sometimes referred to as a database. The equivalent level in Couchbase is a bucket. Next down you have schema. The equivalent in Couchbase is a scope. We don't often use schema too much. We'll just use DBO sometimes. Same thing at Couchbase. Sometimes we just use underscore default. But if you need it for microservices or multi-tenancy, that's a very good construct to have there. Next one down is table. This is the one we're most familiar with. The NoSQL equivalent of that is roughly collection. The difference here is that when I create a collection, I don't have to create a bunch of constraints and field names and data types up front. It's just something I can put my JSON documents into. The next one is rows. Rows go in a table. Documents go in a collection. The difference here is that I get flexible JSON as my data instead of data that has to match that column. SQL Server's language is T-SQL, Transact SQL. Couchbase uses SQL++. I mentioned that already. You can have a primary key in relational databases. In document databases, you have a document key. Very similar concepts. Indexing is also, you need indexes on both for performance reasons, right? Okay. So that's kind of a translation guide that I like to think in my mental model of how do these concepts match up to the relational world. So I'm going to assume you have some familiarity with SQL already. If not, that's okay. Don't have to leave the room. But just know that SQL is very popular and it's used by pretty much everyone who works with data. Not everyone, but a lot of people. And so what I hope to show you is that SQL++ is not all that different, but you still get the benefits of a flexible JSON NoSQL database. So I'm going to start with some sample data first before I can actually show you the queries. And I'm going to use some airline data. So this is a sample route document. And this exists in a collection called route. Right? But it doesn't have an enforced schema or anything like that. It's just whatever valid JSON I want to put in there. So each document has a key. The key for this document is route_5966. You can see that there at the top. Now in the JSON, notice that there is both a source and destination airport. So this is, I think, Orlando to Seattle, something like that. And also notice the airline ID up there. So it's kind of like a foreign key, but it's not a foreign key. There's no constraint on that. It's just pointing to another piece of data in the system that has information about the airline. And there's also a schedule field. This is an array. In relational, this would typically be another table. It'd be 3 rows, probably normalized into another table. But in this case, it's all embedded here in the route document. Okay. Now let's go over to an airline document. So this is in a collection called airline. It's very flat data here, very much like you'd see in a row of data in a table. So you can probably imagine how SQL would work on this data here. But this contains the name of the airline. So this has American Airlines. This one just has the ID of the airline. So you can see it's kind of, they're related to each other. So let's look at a select query on JSON data with SQL++. So this is pretty much how you'd expect it to work in a relational database, right? A select query, some fields, from routes, and then limit 10. Now that syntax might look different in SQL Server, but I just want the first 10 results. The result of this would be JSON data. So not rows or columns, but an array of JSON results. So you can see there, it might be a little hard to read in the back, but the results have airline ID, destination, and source airport. That information it's not really ready to be seen by a customer, right? Customer doesn't know what airline 137 is, right? So we're going to have to we have to get that airline name somehow. So in a NoSQL database that doesn't have joins, this becomes kind of a modeling decision. All right, so do I go back to all these routes and look up the airline name, and I could store them here in my document, kind of like a cache. I'm duplicating data so that next time I get it, I don't have to do 2 lookups to get the airline name. So I could just store Delta right here in JSON. This would be frowned on in a relational database, right? You wouldn't normally do this. That would violate third normal form, right? But it does eliminate the need for a join. So it may improve our performance at the expense of duplicating data, which in this case is probably fine. How often do airlines change their names, right? Maybe every, decade-ish. So this is not a big deal. We can make this decision, and that will give us some performance benefits, and that will be fine. And storage these days is way cheaper than it was when these relational databases were first invented. So this is not going to be a real killer for us if we decide to do this. So that's still an option. That's always on the table. Another option is we could still do a join if we're using SQL++. So maybe the data does change often. Maybe it's something else besides the airline name that changes, weekly or daily. We still want to be able to join that, and duplicating the data would be maybe, too much work or too many risks to it. So we could do a join here. With SQL++, we can do inner join, left join, right join, just like in a relational database. And so this is what a join query would look like. We're just getting the airline name from that other collection, the airline collection, and joining it on airline ID. Now you might be wondering about that meta keyword there. It's a little weirdness, right? Now remember that each document has an ID, and in the case of Couchbase and other databases, the ID is technically not part of the data, it is metadata. So that's why we're using this meta keyword to get the key of that document. That might vary from database to database, but all I'm saying there is join on the key. The results would look like this. So now we've got airline 137 is Air France. So now we can show it to the customer. Now a join is still overhead here. Just like relational, it's still extra work we have to do. But with some modeling and some embedding, we can almost always reduce the number of joins that we use. Even if we don't eliminate them completely, we can still reduce that overhead with a JSON database. Now I mentioned Cosmos and Dynamo earlier. They do not support joins like this, at least not yet. So a join between 2 documents is not something that those implementations supported just yet. All right, we can get even crazier with this now. This really shows, I think, the power and expressiveness of SQL and concise nature of SQL. So I want to know which airlines are the biggest, which have the most routes. So I'm going to use an aggregate function in this case, count, and a group by. And I'm going to qualify the aggregate by using a having. Anyone use a having before in a query? Yeah, that's relatively common, right? It's a really handy thing to do if you want to filter aggregates. I'm going to restrict this to the biggest airlines that only have 2,000 routes or more. And then I'm going to order by the highest count. Okay? So this kind of query is very concise and readable with SQL. Creating this with a different language that's not as declarative would be a lot more code to write. And it can be run on JSON data. So these are the results we get. We can see in my data, American Airlines is the biggest, 2,354 routes. So we've got 8 lines of SQL to give us that information. I think that's a really powerful way to express queries is SQL. So hopefully I'm preaching to the choir here. SQL is good, is what I'm saying. All right, so I could go into a lot more detail about selects and different syntax, insert, update, delete, merge, all that kind of stuff. But I want to show some more features that I think might be interesting. You can look all that stuff up in the documentation, but I want to show some stuff that you might not be aware of that SQL++ can pull off. This is a simple demonstration of ACID transactions, right? I have 2 different accounts. This is the classic ACID example, right? Each one has a balance. So we've got Matthew has a balance of 1,400, and Emma has a balance of 0. So I want to transfer some money from Matthew to Emma. Emma's my daughter's name, by the way, so I'm always transferring money to her. But in the case of this, we have 2 different pieces of data, and if you're familiar with accounting, a debit and a credit both have to happen. If only one of those happens, then we're going to be either creating or destroying money, and we can't really do that. So if we're transferring money, we have to do the credit and the debit, or neither. That's the ACID transaction example. A halfway is not acceptable. So how you do that in SQL++ is just the way you do it in SQL. You have a begin transaction, a couple update statements, maybe a select to verify that the new data, shape of the new data, and then commit transaction. You could also do a rollback, a save point, all that kind of stuff that you're used to in the SQL world for more complex scenarios. Now this is, in the case of NoSQL, a distributed transaction. So these pieces of data, Matthew could exist on node 1, Emma could exist on node 13, for all we know. So it's two different nodes, two different servers. This is being coordinated over a network. So there is overhead to this. There is definitely overhead to an ACID transaction in a distributed database. So if you can model your data to avoid these, you can still go that route. But the ACID is there when you need it. Indexing is an important part of SQL queries. Anybody here good at writing indexes? Yeah? Okay, one guy claims to be. All right. Anybody not write indexes at all? That was me when I first started. Just, query it, it'll be fine. Until, we hired a DBA and he's like, what are you doing? So indexing is an important part of SQL queries. It's an important part of SQL++ as well. The syntax is very similar. It's create index. Create primary index is an index you could create that enables SQL queries to scan everything. This is not a good idea to do in production because this will be a very slow query. But in development, as you're working on those queries, it might be a good idea to just enable everything so you can get started and then index later. Right? Index later. We're going to index later, right, guys? Yeah. And the second one is an index on some fields. So this is, we're indexing the route collection in this case, which is part of the inventory scope, part of the travel sample bucket, back to that table I showed you earlier. The first index is not good for production, I mentioned, but if we're going to query on the source airport, for instance, we might want to create an index like this to index that source airport field on the JSON data so that we can have a more performant query. I guess I forgot some underlines here to help you. So bucket scope collection, and then fields or expression. You can scope on functional things, tokenize, whatever you want to do with the index. You can get very complicated with that. So relational world indexing is a very deep topic. I'm not going to get into that too much. It's something of an art form. This guy knows over here. But fortunately for us, there's an index advisor available. A lot of relational databases have this too, but it can make recommendations for indexes. We can put in our query, and the index advisor can say, here's our query, can say, oh, here's a better index for you. Maybe a little difficult to read this, but there's an advise button up here. We click that, and it spits out, here's some recommended indexes for you. So again, it might be hard to read, but I've entered a query for airline routes at the top, and I click advise button. And now you shouldn't necessarily just blindly add these indexes, right? But it's not always going to give you the absolute best index. Like I said, it's an art form sometimes. But it's going to give you a place to start. It's going to be better than a primary index. And I'll show, if we have time, I'll show you some more about indexing and query plans in the demo when we get to that. But it's important to have an advisor handy that will help you at least get in the right direction. Okay, now, let's say you had a ton of indexes in your system, and they all made sense at some point to create, right? So I've got, 13 indexes here that index all different combinations of name, zip, and status of my customer collection, right? And if you're using a rule-based optimizer, you might want to have variations of this. Name, zip, status is different than zip, name, status if we're following a rule-based optimizer. So putting those expressions in a certain order in our SQL query can lead to better performance, right? So I want to say where name, where zip, where status, that'll use index 1. If I say where zip, where name, where status, or where or, I guess, that would be index 2. Right? Now, suppose I want to run this query here. Which indexes should be used for this index, right? Well, if we're using a rule-based index, it's probably going to go name, zip, status. But which one should be used? The answer is my favorite answer of all, it depends. Okay? Because our data will have different cardinality for each one of these fields. I'm not going to go too deep into cardinality, but let's just say, what if there are 5 different zip codes in my system, period, and what if there's 5 million? There's different cardinality with that. Or there's 5 million mats, or 5 mats, right? So if there's fewer mats, I want to filter by mat first to limit my results as much as possible. So with JSON data, it gets even crazier because it's possible that zip code is a string in some documents and a number in other documents. Now, I'm not saying you should do that. Don't do that. But it's possible. It's technically possible. So that's something that a cost-based optimizer has to take into account. So if you're familiar with this in the relational world, it's usually done via statistics, right? You have an update statistics for a table. Do the same thing with SQL++. Update statistics for a customer, status name zip. And when you have statistics in place, then the cost-based optimizer will say, okay, this will be the best index for me to use because cardinality for zip is such and cardinality for name is something else. So I can better pick the best index for the job. All right. User-defined functions. Anybody using UDFs in their relational databases today, or SPROCs, I guess, stored procedures? Okay. Okay. I'm not a huge fan of that kind of stuff. I like to keep as much logic as I can out of the database, but some organizations, some teams really like them, and sometimes they're very warranted. User-defined function allows you to write functions with SQL. Do the same thing with SQL++. This is a function to list airlines by rank for a given country. And this is about as close to a stored procedure that Couchbase has right now, user-defined function. It's not exactly the same thing, but sometimes there's overlap between them. Cosmos DB also has stored procedures, but they are, I believe they're JavaScript only at this point. So you got to write them in JavaScript, not SQL++. Okay. Eventing. Anybody use triggers? The dreaded triggers. Yeah, okay. So this is somewhat related to triggers in SQL++. This is called eventing. This allows you to write code that responds to data changes. Now, it's not the same thing as a trigger because it's not going to do any sort of locking on the data. This is a contrived example of this code up here, but it's going to execute whenever a document is updated. Now, if you notice, it's in JavaScript, but there is some embedded SQL++ there. You can see var results equals such and such. That's embedded SQL inside of JavaScript, which I think is pretty cool. It can actually parse that out. This is another way you can add logic close to the data, create an update or delete event that responds to data changes. Now, it's not quite a trigger, right? It doesn't block anything. It can't check constraints. It's asynchronous, but it's very similar to that kind of functionality. The last one I'll talk about is analytics. This is just the one slide I'm not going to go through the whole thing, but SQL++ can also be used for analytics, so BI use cases and analytics type use cases. Couchbase offers analytics, an analytics service. It's also SQL++. This is often referenced as, anyone heard of HOAP or HTAP before? HOAP, HTAP? Is that a term that's gone out there yet? So it's just basically, as opposed to your OLAP data, now you have your OLAP data. The equivalent in NoSQL world is your HOAP or HTAP data. So this is for ad hoc queries, very complex queries that are not something you deploy to your website that get run hundreds of times, but it's something that your BI, your analyst is going to run or create reports from. And the idea here is workload isolation, so you can run those queries on your analytics copy of your data without impacting the workload of your operational data. So me running a complex reporting query is not going to take down the website or slow down the website, that sort of thing. I'm not going to say anything more about that unless I get questions, but it does use SQL++. It can also connect to other sources outside of, in this case, Couchbase, so like S3, blob storage, data lake, Parquet, things like that are all options to bring in that data. And I usually get questions about how do I move my data from relational to NoSQL. I want to try this stuff out. There's lots of tools out there. The usual ETL tools apply, but you can build an ETL, you can set up a Kafka queue, whatever. I wanted to point out two that I think are very cool. These are specialized tools, DataWorks and GlueSync, and they can do live synchronization of data from relational world over to a database like Couchbase or Mongo or whatever. It can do that point in time, or it can do it live, like real time. So you can have both systems running for a certain period of time, or indefinitely, if you want to use NoSQL data for a certain use case, but keep your relational database around. The other thing that DataWorks can do, I think they both can do this, but remember when I went from that 5-table model to the 1 document model? These tools can actually have some UI, some point-and-click type interface. You can configure that, and you can say, well, I want the purchases data to be embedded into my customer's data. So not only do they copy the data, they also copy it and remodel it for you into a more optimized JSON model. So I think that's a pretty cool feature. All right, I'm about to go to a demo here. I'm going to show you the easiest way to get started with Couchbase and SQL++ is something called Couchbase Capella. This is Couchbase's DBaaS, our SaaS offering, completely managed and hosted database as a service. There's a 30-day free trial if you want to do that right now. It's no credit card needed for that. You get up and running in minutes, and you can start querying that same travel data I've been showing you for most of the session here. And you can also start writing code with your SDKs if you want to connect an app to it and try it out. SDKs are available in all those different languages, .NET, Java, even stuff like Kotlin and Scala's out there you can use. So let me do a little switch here, okay? Of course, I get a timeout. All right. So this is Couchbase Capella. I've got a single cluster here called trial cluster. I can have multiple clusters, of course, but we'll go into that. I've got a bucket here called travel sample. And I'm just going to go into query workbench. And this is where I can start entering SQL queries and executing them. So I'm not going to make you watch me type, but I've got a query here. There's a landmark collection, so it contains things like hotels and restaurants and stuff like that. And I want to select all my landmarks that have breakfast in the content. I guess I was hungry when I was writing these samples here. So this is the like operator with wildcards like you typically see in the relational world. And I just want the first 10. Let's go ahead and execute that. Oh, I forgot to select bucket and inventory scope. Try it again. So there's the results. You can see the first one is for Chibo, okay? And some sort of restaurant of course, it's in California on Sunset Boulevard. So there you go, and there's 10 results total, so they're all there in JSON. I could put them in a table view, which kind of works a little bit. There is some embedded JSON in there, but it's kind of a flatter view if you like that view. It's still JSON behind the scenes, but nice table view of it. Okay, so that's just showing wildcards off there. What else do we got? I would say if you're doing a lot of text-based searches, something you should consider instead is full text search, which is also built into Couchbase. It's a Lucene-like search engine on the same pool of data. So you don't have to connect to another database to do search. So here is interesting query, because this is going to deal with arrays in JSON data, right? So how do we actually go through and filter data that's based in arrays? So some syntax here that kind of looks like a lambda, where any S in the array, schedule, satisfies this condition. The flight is AF547 end. So that's like a little expression we can write in SQL++. You're not going to see that in the relational world because you're not going to see arrays in a relational table. So that one took a little bit of time to run, but there we've got the results. AF547 is right there. But it returned the first 10 that have that flight number. So what we could do is we could click on advice here and see what kind of indexes we could create. That might be better for that. So again, kind of hard to read, but it looks like it's telling me to create this crazy looking index right here, distinct array, flight, 4S, and schedule. That's not something, I'm not good at indexing. That's not something I would come up with out of my own head. So this is giving me some value right away by saying, hey, apply this, it's going to make your query faster. Again, you want to consult this guy to make sure that's the optimal query, but this is a good place to start as an index advisor. All right, what else we got in here? What are we doing on time? I think we're fine. This is some pagination. Often you'll have to, you want to get a page of results. You don't want all 1 million of your landmarks. You just want like 10 at a time or 50 at a time. So offset and limit syntax, just like you'd see in MySQL or Oracle to do that sort of thing. These are ones I get asked about a lot, like can you do paging? Can you do this and that? What about arrays? Here's a funky one here with a sub-array, subquery. I want to select landmarks that happen to be in the same city as an airport. So it's a kind of like a join, but I'm going to do a subquery to filter on the where. So we'll go ahead and execute that. And there we go. So now I've got Abbeville, Avignon, and a bunch of other cities. How many? 2,776 landmarks that are in same city as an airport. But there's duplicate data here, right? So that's no good. So we've got to use a distinct keyword on that. I don't know why I'm copying and pasting just the word distinct, but there you go. Now we have 84 landmarks that happen to be in the same city as airports. So just kind of driving the point here home that there's a lot of query languages out there that kind of look like SQL, but this is really a full SQL implementation that has everything you'd expect from the relational databases you're used to working with. So that's what I got for demo here today. Any questions before I switch back to slides?
I have a question for you.
Yeah, go for it.
You had SQL++ embedded in JavaScript.
Yeah.
But there wasn't any context at all. What was going on there that you
Yeah. So what's the question? Where was it? It was right here. Yeah.
yeah. So, like at what point were you talking to the database?
Okay, so the question is, what point are you talking to the database? So this function actually exists on the database, right? And is executed when when any sort of document updates. So if
Yeah, so that's what I said. So
yeah.
JavaScript, how like that's a living update.
Yes, so this function is deployed to the database. That was, the question was, where does this live? Yeah.
Yeah, so is it just JavaScript to do that, or
Okay.
you mentioned other languages?
Yeah.
Yeah.
Yeah. Okay. So the question was, is it just JavaScript for this? I believe right now it is JavaScript / SQL++, as you're seeing here. I believe in developer preview we have some Python. I'm not 100% sure on that, but Python's another language that's very popular for some AI and ML use cases. So that's something that I think is being explored as something to add to this eventing system as well. Yeah. But other than that, no, it's just JavaScript, Python in preview, and then SQL++. Yeah. Yeah. Is that 10 minutes? Is that what that means? Okay, good. All right, we got 10 minutes left, so I got plenty of time for questions. I'm going to go back here to finish up the slides. Couchbase Capella, I mentioned that. All right. Another thing that's pretty cool, you might want to check this out, is the Couchbase Playground. You can do this, well, I wouldn't recommend doing it on your phone, but you can do this right now in a browser. Go to couchbase.live. It's totally free. You don't even need to leave your browser to try out Couchbase. Step-by-step guides there for all these languages, but mainly I want to focus on SQL++. There's lots of examples that are already pre-written, but it's a playground, so you can actually go in there and change the code and experiment with it and execute those right there in your browser. You can also get a sandbox session going, so you can get some connection strings. You can connect up your, an app running on your laptop, for instance, to connect to these databases to try out some .NET code or Java code or whatever that uses Couchbase. Some samples are in there for that as well. And so that is like a 30-minute trial. And if that's too short, you can then go to Capella, which is a 30-day trial. So there's all these different things. You can go from completely unlimited but browser-based to a sandbox, 30 minutes, to the full trial at 30 days. Those are the options there. I guess I jumped ahead of myself. This is where I'm going to put the demo in, but I already did that. So that is it.